Alright, so this video is about thermal energy, but it's part 2 of this topic, so we're going to continue where we left off. So the size of an object affects how much thermal energy it has. So if the object is bigger, it could possibly have more thermal energy than something that's small. So a large iceberg has more thermal energy than a small pot of boiling water. Now granted, the boiling water has a much higher temperature because those particles are moving around very fast. But since the iceberg has so many more particles to begin with, when you add up all that energy, it still has more thermal energy than the boiling water. So size is important, but also how fast the particles are moving. So the iceberg has many more atoms, which gives it more thermal energy. So the more atoms it has, it could possibly have more thermal energy. It depends on the size and the temperature. And speaking of temperature, temperature measures how much thermal energy an object has. So the faster those particles are moving around, the higher the temperature. If the particles are moving very slowly, or those atoms are moving slowly, it has a lower temperature. So temperature tells us how fast are those atoms moving in that object. So thermal energy moves from hotter substances to cooler substances. It always moves in the direction of hotter to cooler. So if you have two objects, one is hot, one is cold, the thermal energy is going to transfer from the hot object into the cold object. Every time, always. Hot to cold. Even if an object is very cold, it will transfer its thermal energy to an object that is even colder. So say you have like a glass of water and it was been in the refrigerator. It's cold, so it doesn't have a very high temperature. Its particles, its atoms are not moving very quickly. So your glass of refrigerator water is fairly cold. But then if you put an ice cube into it, it's even colder. So the water, in this case, is the hotter object. So it is the warmer of the two. So the water will transfer its thermal energy into the cooler substance, which is the ice. This thermal energy always moves from hotter to cooler, even if both of those things are very cold. And the opposite is true as well. If you have two objects that are very hot, it will go from hotter to cooler. So say you have a very hot pan, and then you put some soup in it that's already warmed up. The pan, which is very hot, will transfer its energy into the soup, which is warm as well. So whatever is hotter loses its energy and gives it to the cooler object, always. So, objects will transfer thermal energy from warmer to cooler, like we said, until the temperatures of both objects are the same. So the hotter object will give off its thermal energy to the cooler object until both temperatures of both objects are the same. And this is called thermal equilibrium. E-Q-U-I-L-I-B-R-I-U-M. Equilibrium. And that just means that the thermal energy is equal. Okay? So for example, I like talking about soup today. We have a bowl of soup here with a spoon in it. The soup is hot. It's 100 degrees Fahrenheit. It just came out of the pot on the stove. The spoon is not hot. It is 50 degrees because it's been in a drawer in your kitchen. So the soup is really hot. The spoon is not. So the thermal energy from the soup is going to transfer into the spoon because the soup is the warmer of the two objects. So from warmer to cooler. So the energy is going to go from the soup to the spoon. And since they're touching, the soup and the spoon are touching each other, that is through conduction. We learned that in the last video. So they're touching, so we're going to transfer thermal energy from the soup to the spoon via conduction. So the temperature of the soup is going to go down as it loses its thermal energy, and the temperature of the spoon is going to go up as it gains thermal energy. And they're going to keep transferring that energy over until their temperature is the same. So when the soup reaches 75 degrees, because its temperature has gone down because it lost thermal energy, when the soup reaches 75 degrees, the spoon is going to reach 75 degrees because its temperature has gone up because it gained thermal energy. So now the soup and the spoon are the same temperature and we've reached thermal equilibrium. So the transfer of the thermal energy will stop at that point. They'll just sit there and hold their thermal energy that they have.